Okay guys, we're going to solve logarithm equations. So we're going to talk about logarithmic equations and we're going to solve them. Okay, before we can solve, we need to do a quick review over how to rewrite logarithms as exponents. So when I rewrite, we're going to take our base, which for this is 3, okay, and then we're going to rewrite this as an exponential. So 3 to the 4th equals x. Right, now on the next one, same thing, our base is 5. So 3 to, remember, logarithms equal the exponent, so 5 to the 3rd equals 5x. Okay. Now, this is going to be helpful because when we start solving these logarithm equations, we're going to use rewriting as an exponential to help ourselves out with these. Okay, so when we're solving logarithmic equations, first thing we want to do is make sure that it is a single log. Then we're going to go ahead and rewrite it as an exponential, solve for x, and then check for an extraneous solution. Why do we have to check for an extraneous solution? Because one rule with logarithms is we can't have logs of negative numbers. So once we get our x equals, we plug it back in to make sure that it doesn't be a log of a negative. If it is a log of a negative, it would be no solution, or that x does not work as a solution. If it's positive, it works out, and that would be our answer. Okay, let's look at this first example. Okay, so we have a logarithm base 5 of x minus 2 equals 2. So first thing we need to do is make sure we have a log equals a number, which I do. So let's go ahead and now rewrite this. Okay, so we're going to have 5 squared equals x minus 2. Now once I have that, I'm going to go ahead and solve for x. First thing though is 5 squared. Well, 5 squared is 25 equals x minus 2. Okay, so then now I'm going to add 2 to both sides. Okay, so I'm going to have 27 equals x. Now the last thing I need to do is I need to take that and plug it back into this x right here. And I just want to make sure that this thing in the parentheses is not a negative. So I'm going to have 27 minus 2. Well, 27 minus 2 is 25. Okay, it's a positive, so I know that I'm okay. So I'm going to go ahead and say that that is my answer. Okay, if it was a negative, we can't do a log of a negative. But since it's a positive 25, we're okay. Now, here's our next example. It's going to be a similar thing. We have a log equals a number. It's okay that it's a fraction. Let's just rewrite this. We have 8 to the 1/3 equals 3x minus 10. Okay, now don't freak out because it's 8 to the 1/3. Remember, that's just the cube root of 8. Well, if I need to use my chart, the cube root of 8 is 2. Okay, so 2 equals 3x minus 10. Okay, so let's add it. Solve for x now. Add 10. So 12 equals 3x. Okay, divide by 3, so x equals 4. Okay, now let's just double check to make sure that it doesn't end up being a log of a negative. So we have 3 times 4 minus 10. Well, 3 times 4 is 12. 12 minus 10 is 2. So it's still positive, so this one is going to work out for us. Okay, for this one, remember ln is just log base e. Okay, so when I rewrite this, this is just going to be e squared equals 5x minus 3. Okay, now e squared, when I do that, that ends up being 7.389 equals 5x minus 3. Remember, we just do e squared in our calculator. And it does kind of keep going, but then I'm going to go ahead and add 3. So I'm just going to hit plus 3 and do it on my calculator, which ends up being like 10.389. Okay. I'm rounding it when I'm writing it, but I'm just going to go ahead and use the same number on the calculator. So I'm just going to add 3, and then that equals 5x. Then we're going to divide by 5. So x ends up equaling 2.0778, so let's just round this to 78 right there. So then that's our answer. Now let's just plug it back in. We just want to make sure that this does not end up being a negative. So 5 times 2.078 minus 3. Once I do that, well, that's going to be 10 point something minus 3 is still positive, so this ends up working out. How do you know if an answer is extraneous when solving logarithmic equations? Well, we just can't have logs of negative numbers, so when we plug it back in, if it ends up being a log of a negative number, it is going to be extraneous, and it's going to end up being no solution, or that solution does not work.